Hello, so I'll assume that everybody has watched the previous video. I wanted to give you some examples for calculating both your dilution factor and your total dilution. Remember that we're looking to find the concentration, in this case in CFU per mils, of your starting solution. But that starting solution is too concentrated to be able to count directly. If we put a little bit of that solution onto a plate and let them grow, we would have too many colonies or too many colony forming units to count, or we would have had too small of a volume to make them be able to be counted accurately. So we want to dilute our starting solution in such a way that we can get eventually between 30 and 300 colonies on a plate. We consider this to be a countable plate. And then we want to be able to count colonies and use the dilution factor, the total dilution of the particular plate, to calculate the concentration of colony forming units in your initial solution. So here I'm going to imagine I have some sort of a stock solution that has a whole bunch of bacteria in it, and I'm going to demonstrate a number of serial dilutions. For first case, I'm going to imagine that I have a container that has 99 milliliters of sterile diluent. And I'm going to pick up 1 milliliter of my stock solution and mix it up in that 99 milliliters. To calculate my dilution factor, I would have how much I moved into my container, so 1 milliliter, divided by how much is in that container right now. So that's 99 milliliters that were there at the beginning, and the 1 milliliter I just put in, so 1 over 100. If any of you remember, 1 over 100, 100 is the same as 10 to the second, and from algebra you might remember that 1 over an exponent is the same as to the negative exponent. So 1 over 100 is the same as 1 over 10 squared. 1 over 10 squared is the same as 10 to the negative 2. So my dilution factor for this particular dilution step, where I took 1 milliliter and put it into 99 milliliters, is 10 to the negative 2. I've so far only done that dilution, so at this moment my total dilution is also 10 to the negative 2. Now let's see what would happen if I did this again. And in this case, I'm going to imagine that I have a container with 9.9 milliliters. And I'm going to imagine that instead of taking 1 milliliter, I take 1/10 of a milliliter, 0.1. Now I have a dilution where I moved 0.1 milliliters, I moved it into 9.9 plus 0.1 milliliters. So that's a total of 0.1 over 10. 0.1 over 10 is exactly the same as 1 over 100. I could multiply both 0.1 times 10 to get 1 and 10 times 10 to get 100. So once again, this is a 10 to the minus 2 dilution. To calculate the total dilution, I'll take the dilution of the first step, multiply it by the dilution of the second step. 10 to the negative 2 times 10 to the negative 2 is 10 to the negative 4. So remember, when you have the same base, you're multiplying numbers with exponents, you can just add the exponents. 10 to the minus 2 times 10 to the minus 2 is 10 to the minus 2 plus minus 2, 10 to the minus 4. One more step that I want to show you. Here I'm going to imagine that I have a container with 9 milliliters of fluid, and I'm going to once again move 1 milliliter. I moved 1 milliliter. I have 9 plus 1, or 10 milliliters total. 1 over 10 is the same as 1 over 10 to the minus 1. Sorry, 10 to the positive 1, which is the same as 10 to the minus 1. So I had 10 to the minus 4 since the beginning, since the stock solution, by the time I got here. 10 to the minus 4 times 10 to the minus 1. This dilution is 10 to the minus 5. Notice that your units, your milliliters, are canceling out. So you have milliliters divided by milliliters. That means your dilution factor has no units. It's just a how concentrated is this compared to that. If I imagined that I had a concentration in my stock solution of, let's see, 3 times 10 to the 5th colony forming units per milliliter. If I diluted that 1 to 100, and then I put onto a plate 1 milliliter of that, I would expect to have 3 times 10 to the 5th times my dilution factor of 10 to the minus 2, or 3 times 10 to the 3rd, 3,000 colonies on my plate. That's way more than my 30 to 300 countable colonies for a countable plate. If I plated 1 milliliter of this concentrate, this solution, 10 to the minus 4, I would have 3 times 10 to the 5th times 10 to the minus 4 equals 3 times 10 to the 1st, or 30 colony forming units, which is just about what I want. Here, if I plated 1 milliliter, I would have 3 times 10 to the 5th times 10 to the minus 5, so 3 times 10 to the 0. 5 minus 5 is 0, so I would expect to find 3 colonies on this plate. Whenever you are doing a serial dilution, you want to plate what you think will give you 30 to 300 colonies, so that. But our initial concentration is always an estimate. We don't know precisely how many colonies there are in that initial plate. So we do something that's called bracket plating. We plate the concentration we think that will give us what we would like, but we always plate one thing that is a power of 10 more diluted than that, and we would need to set in here another serial dilution to give us something with a 10 to the minus 3 dilution, so that we can plate something that is a power of 10, or we expect to be a power of 10 to concentrate it. That way, if our estimate is wrong, and if this plate that we think will give us a countable number of colonies gives us too many or too few, we could use a plate on either side to calculate our initial concentration. So let's see how that would work. Let's say that I plated my colonies, and let's say that I plated a plate with a dilution factor of 10 to the minus 4. And when I went to my petri dish and I counted them, I found 56 colonies. The equation that you want to use to calculate the concentration of your stock solution, thing you began with, is concentration, so CFU per mils of your stock, or whatever your concentrated solution is, equals how many colony forming units you counted on your plate, divided by the volume that you put onto your plate, times the dilution factor. So how diluted is your plate compared to your stock solution. We're going to imagine that we had put 1 milliliter on. If you put 1/10 of a mil, 0.1 mil, you would end up with 10x fewer colonies. But your directions count or call for putting 1 mil onto the plate, so we're going to imagine that. My initial starting colony forming units per mil, so in that stock solution way back at the beginning, equals 56 colonies, so 56 colony forming units, divided by 1 milliliter times a dilution factor of 10 to the minus 4. So 56 times 10 to... Oh, excuse me, sorry. Let me say. 56 over 10 to the minus 4. My units are colony forming units per milliliter. But we can simplify this fraction significantly if we remember the rule about moving exponents to one side of the fraction and changing their sign. This is just 56 times 10 to the positive 4 colony forming units per mil. And I can move the decimal that's way over here back right here to make it proper scientific notation. 5.6 times 10. And instead of times 10 to the 4, I've moved my decimal place just once. To make this number smaller, that means I need to multiply by another power of 10 here. So times 10 to the 5. You could always leave it unsimplified if this simplification, this last 556 times 10 to the 4 versus 5.6 times 10 to the 5 confuses you. My units are still CFU per mil. So for your lab, you've read the directions for the serial dilutions that you were instructed to do. I will give you data for both A and B, and you should make the calculations, calculate the initial concentrations for A and B. Make sure that you can do serial dilution problems. You have some examples in the lab. You also have, at the end of the lab manual, an appendix with some practice problems. Thanks much, and goodbye.